In this video, we will understand the polar plot for type 1 system. The type 1 system, I have taken third order type 1 system. G of s is equal to k divided by s into 1 plus st1 plus 1 plus st2. For this, first we will write g of j omega, that is sinusoidal transfer function. This is equal to k divided by j omega 1 plus j omega t1 and 1 plus j omega. This is the sinusoidal transfer function. The magnitude of this transfer function, g of j omega, is equal to k divided by omega root of 1 plus omega square into t1 square root of 1 square root of omega square into t2 square. This is the magnitude, and angle of g of j omega is equal to minus 90 degree minus tan inverse omega t1 and minus tan inverse omega t2. So this is the angle and magnitude respectively. Now we need to find out the real and imaginary part separately, so for which we need to rationalize this expression. Rationalizing the expression. So when we rationalize it, g of j omega is equal to k divided by j omega 1 plus j omega t1 1 plus j omega t2 into minus j omega conjugate of this function into 1 minus j omega t1 into 1 minus j omega t2 whole divided by minus j omega 1 minus j omega t1 into 1 minus j omega t2. So you need to simplify this function and then we can separate the real and imaginary part. So the entire calculation is given in the notes. I straight away write the real and imaginary part to save time. So real part of g of j omega is equal to minus k t1 plus t2 divided by 1 plus omega square t1 square 1 plus omega square t2. Similarly, the imaginary part of g of j omega is equal to minus 1 minus omega square t1 t2 divided by omega into 1 plus omega square t1 square 1 plus omega square t2. So with this we know that t1 t2 is greater than 0. So your real part will always remain negative no matter what your omega value is. The real part will always be negative. It will always be negative no matter what omega value you have. Irrespective of the omega value, it will always be negative because you have a negative sign. And t1, t2 is greater than 0. Coming to imaginary part, here the imaginary part of g of j omega, this will remain negative when omega square t1, t2 is less than 1. If it is less than 1, the imaginary part will be negative and it will be positive when omega square t1 t2 is greater than 1. So there are two conditions for imaginary part. It can be negative when omega square t1 t2 is less than 1, and when omega square t1 t2 is greater than 1, it is positive. So real part will always be negative. Coming to the S plane, this is the first real and this is the imaginary. So the real part will always be negative. It means that the these are the two possible quadrants when we consider, sorry, these are the two possible quadrants when we consider the real part. And the imaginary part can be negative and positive. So it can be negative in the sense, imaginary part, it can be negative or positive. So all the four quadrants can, the polar plot can be available in all the four quadrants. I'm sorry, I'll repeat again. The real part will always be negative. So these are the only two possibilities for that. And the imaginary part can be negative or positive. So it can be either negative or either positive. So the your polar plot will only be in this quadrant, that is second and third quadrant. Your polar plot cannot exist in first and fourth quadrant because here the real part is positive, but from our observation we can see that the real part will always be negative. So the possible areas where you can find the polar plot is only second and third quadrant. Now we will tabulate the results. So omega tends to 0, tends to infinity. Real part of j omega, imaginary part of j omega, then magnitude of j omega, angle of j omega. So now when omega tends to 0, what about the real part? So when in this part, when omega tends to 0, so this term gets neglected. So what remains is minus k t1 plus t2. Minus k t1 plus. Coming to the imaginary part, this term gets 0. This is 0, this is 0. So what you have is minus infinity. This is nothing but the magnitude of this will be again infinity. The angle is equal to here. So this is the, so here you can see minus 90 degree minus tan inverse omega t1 minus tan inverse omega t2. So it is minus 90 degree minus 0 minus 0. So this is equal to minus 90 degree. Similarly, when omega tends to infinity, so this is infinity, 1 is ignored, this 1 is gets ignored. So 1 by infinity, it is 0. It is like we normally call it minus 0 because it is approaching 0 from the negative side. That is the meaning of it. Similarly, I'll just write here. So this means that approaches 0 from negative side. Okay. Next, imaginary part. This tends to infinity. This tends to this is neglected. This is neglected. So when we take that, it is you come up with omega square t1 t2. One is neglected in the expression. So omega into omega square t1 square omega square t2 square. So this omega square gets cancelled. T1 t2 from the numerator gets cancelled. What remains is 1 divided by omega cube t1 t2. So as it tends to infinity, so this becomes 0. Now this is actually plus 0, which means that it is plus 0. This means that it will approach 0 from the from positive side. It will approach 0 from the positive side. That is the meaning of plus 0. So approaches 0 from positive side, and the sum of this is 0. Angle is minus 90 degree minus tan inverse infinity minus tan inverse infinity. It is minus 270 degree. Now let us try to draw the polar plot for this. I will draw the polar plot for this one. So this is the S plane, real part of g omega, imaginary part of g of omega. This is your S plane. Now initially it is minus k t1 t2. So minus k t1 t2 is that is the real part, and imaginary part is minus infinity. So here both are minus. So both are minus. So this particular point will be in third quadrant. So here this is a point. Now this distance is k t1 plus t2. So this is your minus k t1 plus t2 point. Okay, and your imaginary part is infinity. So you can see that no matter what omega value is, this is always constant. This will remain constant. Your real part is irrespective of the omega value, and this is minus infinity. So this point, I'll take this as some point here. This is your minus infinity point. So this is minus infinity minus k t1 plus t2 point. This is the point. So from here you will start. Okay, and then at the end it is 0 and 0. So this is the next point. But here you can see that the real part, it is approaching 0 from the negative side. So this is 1. So here it is approaching 0, and the positive and your coming to the imaginary part, is it is approaching 0 from the positive side. So this is your positive side and this is your negative side. The magnitude is 0, that is this is the point as omega tends to infinity. Now here the angle is minus 270 degree. Sorry, this is minus 270 degree line. So when the polar plot reaches here, it should make minus 270 degrees with the real part, with this axis. So the possible one is this. So here, then from here it should start. Here it should start, and then it should reach this point. So sorry, it should start from here. This is omega tends to 0, and at this point when omega approaches 0, approaches infinity, the line is actually making minus 270 degree. So if it is minus 270 degree, converge it towards the minus 270 degree line. Remember that concept. Okay, so now with that, now we need to see what is this point. This is point A. To find point A, again, find point A. Now here imaginary part is equated to 0. Imaginary part is equated to 0. So when you do that, we get the frequency at which your point A will occur. Now that frequency is nothing but omega is equal to root of t1 and t2. So to get this point, substitute omega is equal to 1 divided by root t1 t2 in real part of g of g omega. Fine, this is how you need to find. So now when you do the substitution part, so what you get is the value of A is, point A is minus K T2 T1 divided by T1 plus T2 comma 0. This is the point. This point A here. This is minus K T1 T2 divided by T1 plus T2 comma 0. This is how you need to draw the polar plot. So I'll repeat again. So initially at omega is equal to 0, real part is minus k t1 plus t2. So draw a line vertically downwards such that the distance from the imaginary axis to that point is k t1 plus t2. So that is the point. So when you extrapolate this point somewhere at infinity, this is your infinity point. Okay, this is omega tends to 0. So from here the polar plot will start. It will cross the real axis and it will merge towards minus 270 degree line. It will, because the angle is minus 270 degree here, that is the reason it will merge towards minus 270 degree line and then it approaches 0. That is when omega tends to infinity. This is how we need to draw the polar plot. Thank you.